Okay, so we have ended over here and we have to start question number 6, right? So look, they are saying there are 4 possible structural isomers of C8H10 containing a benzene ring. Okay. Draw the skeletal formula of the 4 structural isomers in the appropriate boxes. The number of peaks observed in carbon 13 NMR spectrum of each compound is given. Okay. Here they are saying 3 peaks. It means that the 8 carbons are in 3 different chemical environment. Okay. So we have to draw the skeletal formula. Okay. So let's have a look. For example, they have told you that it's a benzene ring. So in the benzene ring, we have a 6 carbon atoms, right? And there is a pi bonding system. And to each benzene ring, there are hydrogen bonded to each benzene ring. Okay, I'm not putting the hydrogen right now. Okay. So its formula is C8H10. If you see at these 4 isomers, here there are 4 peaks, which means 8 carbons having 4 different chemical environment. In the same way, 5 peaks mean 8 carbons, but 5 different environment. And 6 peaks means 8 carbon and 6 different environments. Okay. So if I put a CH3 over here, and if I put a CH3 over here, so the rest of the 4 carbons, each one have a hydrogen. So it's a whole symmetrical molecule. So if you look at this molecule, these 2 carbons are exactly similar. So these 2 would show exactly similar. They have a similar chemical environment. So these 2 would show one signal. If you look at this carbon and this carbon, as these 2 carbon are exactly similar because they are bonded to 2 CH groups over here and one CH3 group. In the same way, this carbon is also bonded to 2 CH groups and one CH3 group. So these 2 carbons will show you one signal. And there are 4 carbon atoms left. And if you look at all of these 4 carbon atoms, these 4 carbon atoms have exactly same similar signal, because on one side of each of these carbon atom is CH, and on the other side there is CCH3. See, this carbon have one side CH3 and on the other side CCH. In this way, this carbon have one side CCH3 and on the other side CH. This carbon have one side CCH3 and the other side CH. So see, we are observing there are 8 carbon atoms, and out of those 8 carbon atoms are actually existing in three chemical environments. So its skeletal formula would be this, and two methyl group exactly on the opposite sides. So that is our isomer 1. Okay. Now, for isomer 2, we need 4 different chemical environments, right? So if I put a 1 CH3 over here and 1 CH3 over here and 4 hydrogens, so let's have a look. These two have a exactly similar environment. Then these two have a exactly similar environment. Then if you look at these two have exactly similar environment, and these two have exactly similar environment, right? So here we are observing 8 carbon atoms in 4 different chemical environment. So the skeletal formula for isomer 2 would be like this. Oh, sorry. It would be like this. Is this clear to everyone? Now, I have the one possibility that is left is that the CH3 bonded to first one carbon and then after another carbon. So rest of the carbons have hydrogens on them. So these two carbons will give you a similar chemical environment, so having a similar structure, also so giving you one signal only. Then this and this carbon would give you the similar chemical environment, so one signal. Then this carbon, as this carbon have both the sides CCH3, so would give you a completely different chemical environment, so a completely different signal. Then this carbon having both the sides CH and CH, so it have a completely different chemical environment, so a completely different signal. And then these two, as these two have a one side CH and the other side CCH3, would give you a different, they both have a similar chemical environment, but obviously different than the others. So see how many signals I am getting now? 5 signals. So this would be my third isomer. Is this clear to everyone? Now, the next possibility, now we can't place two carbons on the benzene ring like this that we did earlier. So there is another possibility that a carbon of a benzene is bonded to a CH2 and that CH2 is bonded to a CH3. And then all of the rest of the carbons have hydrogens on it. So now see, Okay. So this carbon gives you a different signal because it has bonded to 3 hydrogens. Then this carbon gives you a completely different signal because it is bonded to 2 hydrogens and 2 carbons. Then this carbon have a completely different signal than the rest of the benzene ring carbons because it is bonded to a CH2 group on one side and the rest of the 2 sides CH groups. Now, if you look at this carbon and this carbon, these 2 carbons have a same environment. So these 2 carbon gives you a different signal than the rest of them. Then these 2 carbons would be going to give you a different signal and this carbon would give you the different signal. So if you see now there are 6 different environments, so you would be getting 6 different signals. So my isomer number 4 would be this. And as they have mentioned to draw the skeletal formula, that's why I draw skeletal formula in the boxes.
Sir?
Is this clear?
सर ये जो आपने आखिरी वाला कार्बन जो किया है ये ब्लैक ग्रे कलर में, ये भी इसका सिग्नल सेम नहीं होगा? वो भी तो CH साइड बॉन्डेड है दोनों.
With you are talking about that it would have a similar signal with the yellow carbons, right?
येलो कार्बन के साथ सर.
But the thing is that if you look more closely, that yellow carbon have a CH neighbor next to it, and then CH2 over there, right? On one side. And on the other side, there is a CH, and then next to it, there is another CH, right?
Okay, sir.
But if you look at this carbon, there is a CH and then CH again. On the opposite side, there is a CH and again CH. So this makes this carbon completely different than these two.
Okay, sir. ठीक है, समझ गया. Thank you.
Is it clear to everyone else?
Yes, sir.
Okay. A 3-step synthesis of X. Okay, here we would have X. From benzene is suggested as shown. Okay. Step 1 is the alkylation of benzene by electrophilic substitution. So they have mentioned that it is an alkylation. Use RCl to represent this. Okay. Write an equation for the formation of an electrophile from RCl and AlCl3. So if you recall the formation of electrophile, it would be always RCl when reacts with AlCl3, that a chloride ion is removed from here and it would bond with AlCl3 to give you AlCl4 negative and an electrophile R with a positive bond. Is this clear? Okay. Now what they are asking, deduce and draw the structure of W and X in the boxes. Okay. So let's have a look over here. If you look at this, there are 3 CH3 units. So it means that there is a chlorine, then carbon number 1, carbon number 2, carbon number 3. So 3 CH2 groups. Then the 4th carbon have a C double bond OH group. So what happens in the alkylation of benzene, that the chlorine is removed from the molecule and the carbon from where the chlorine is removed is actually bonded to a benzene ring. So the whole structure remains same, and we just bond this carbon with any one carbon of the benzene to form W. Is this understandable to everyone? It's a Friedel-Crafts alkylation. Yes. Is this step 1 is clear to everyone?
Yes, sir.
Now, if you see in step 2, OH group is substituted by Cl group. So that can be done by adding PCl5 at room temperature pressure conditions, or by reacting with SOCl2 at room temperature pressure conditions, or adding PCl3 and heating the reaction mixture. I can use any one of the conditions to convert the carboxylic acid into acid chloride. Now, if you see, you have to identify X. So think, there is no chlorine. So chlorine would be subtracted from the molecule. And if you count how many hydrogens you have over here, 10. Okay. And if we if we write the molecular formula over here, what would find? How many carbons are there? 6, 10 carbons. Let me count the hydrogen. There is 1 chlorine and 1 oxygen. So if you count the hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 carbons. So it is suggesting me that HCl is actually removed from the molecule. So this can be a possibility that chlorine from here and the hydrogen from the neighboring carbon is actually gets removed to form an HCl. And when this happened, see how many carbons? 1, 2, 3, 4 carbons. So 1, 2, 3, and fourth carbon, and fourth carbon have a C double bond O. The Cl is removed from the fourth carbon, and the hydrogen is removed from this carbon from the benzene, and there is a bond over here. So this would be the possible structure of X. Is this clear to everyone? Okay. Now suggest the reagents and conditions for step 2, and we have already decided these over here, so we can write anyone. So I just write, let's say PCl5 at room temperature conditions or at RTP. Is this clear?
Sir.
Okay. Now, part 4. Complete the mechanism for the reaction of a benzene with the electrophile formed in B1. Okay. And they have suggested us that we would consider that electrophile as R positive. Include all relevant charges, curly arrows showing the movement of electron pairs, draw the structure of intermediate. Okay, so what would happen? For example, here I have a R positive. Then I would show a curly arrow from the pi bonding system towards this R positive. And as a result, the intermediate is formed where that R is bonded to a carbon. And on that carbon, now I would show a hydrogen as well that was bonded. Then in the center, now I would make a semicircle with a positive charge. Then from the bond of hydrogen, I would make a curly arrow inside the benzene ring. And here I got R substituted and then put a H positive over here because this hydrogen is actually removed. Yes, is this clear to everyone?
Yes, sir.
Okay. Now question number 7. In aqueous solution, the chlorine dioxide ClO2 reacts with hydroxide ion as shown. Here we have an equation. A series of experiments is carried out using different concentrations of ClO2 and hydroxide ion. The table shows the results obtained. Explain the term order of reaction. So we can explain it as it is the power by which the concentration of a reactant is raised in rate equation. Now, in the next part, use the data in the table to determine the order of reaction with respect to each reactant ClO2 and hydroxide. Explain your reasoning. Okay. So, if I use experiment 1 and 2, there is no change in the concentration of hydroxide ion. But if you see the concentration, there is no change in the concentration of ClO2, but the concentration of hydroxide ion is raised 4 times in the experiment 2, right? So can anybody tell me by which factor the rate is increased? What you have to do, you have to just divide 2.88 exponent minus 3 over 7.20 minus 4. Yes, can anybody tell me the answer?
4.
4. Okay, so here it is 4. So see, the concentration is increased by 4. As a result, the rate is also increased by 4, which indicates that it's a first order. Okay, which indicates that it's the first order. So I can write over here that from experiment 1 and 2, the concentration of hydroxide ion is raised by 4 and the rate is also increased by the factor of 4. Hence, with respect to the concentration of hydroxide ion, its first order. Yes, is this understandable to everyone? Yes, if anybody have any doubt or any confusion, kindly ask. Now, here we take hydroxide ions concentration in account. Now, if I have take chloride ClO2 concentration in account, so I can use experiment 1 and 3, because in experiment 1 and 3, the concentration of hydroxides are same. And there is a change or increase in the concentration of ClO2. So if you see, it is raised by the factor of 2.5 in experiment 3. Is this clear? So by which factor the rate is increased? For that, you have to do this division, that 4.5 exponent minus 3 divided by 7.2 exponent minus 4. Yes, can anybody tell me the answer?
Sir, 6.25.
It's 6.25. So
it will be second order, yes?
yes, it would be second order. And how we will figure it out that it's a second order? Can anybody take the square root of 6.25 and tell me?
Sir, 2.5.
2.5 C. So it's 6.25. So how would you explain or state this? That from experiment 1 and 3, the concentration of ClO2 is increased by 2.5x, but the rate is increased by 6.25. So I can show the working over here. 6.25x. Okay. That the change in concentration is 2.5 and the change in rate is 6.25, which can further be written as 2.5 to 2.5 square. So see, the concentration is raised by 2.5 and as a result, the rate is increased square of this. So I can conclude that with respect to the concentration of ClO2, the order is second. Is this clear to everyone?
Yes, sir.
Okay. Now use your answers to A2 to construct the rate equation for this reaction. Okay. So rate equation would be equal to rate constant K times concentration of ClO2 square as its second order times concentration of hydroxide ion raised to the power 1 as its first order. Is this clear?
Yes.
Now use the rate equation and the data from experiment 1, okay, to calculate the rate constant K for this reaction. Okay, so if I make the case subject, so the expression would be K is equals to rate over square of the concentration of ClO2 times concentration of hydroxide ion, and we have to choose take the data from experiment 1. So in experiment 1, the rate is 7.2 exponent minus 4 divided by the concentration of ClO2 is 0.020. So 0.020 square multiply by concentration of hydroxide is 0.030 in experiment 1, 0.030. Now can anybody solve and tell me the answer?
Say 60.
60. Okay. So the value of K is 60. Now they are asking for the units. So see here it's mole per dm cube per minute, and here we have a mole per dm cubes. Okay. So mole per dm cube per minute over mole per dm cube whole square times mole per dm cube. So these two would cancel out and we are left with minute inverse over mole square dm inverse 6. So if I take them in numerator, it would become mole inverse square dm 6, and minute inverse remains the same. So it would be my unit mole inverse square dm 6 and minute inverse. Is this clear? Yes, is it clear to everyone?
Yes, sir.
Yes, sir.
Okay. Now, the decomposition of benzene diazonium ions.
सर
Yes,
सर ये ऊपर एक से करेंगे टेबल से बना हुआ है
this
टेबल सर
table.
सर देखिए सर हमारा जो OH था वो 4 से हो रहा था ना, तो हमने उसका 1 ले लिया, तो जब 6.25 से हुआ हमारा तो उसको हमने डिवाइड बाय 2.5 क्यों नहीं किया सर?
मैं आपकी बात नहीं समझा.
सर
देखें. 1 minute. in this case, the ratio is 4:1. We are observing that they are changing with the same factor, right?
Yes, sir.
So that's why we said that it's first order. Okay.
Okay, sir.
In this case, what we observed that the concentration is raised by 2.5 and the rate is increased by 6.25.
Okay,
So
sir.
if I figure it out, what I figure it out that 6.25 is actually the square of 2.5.
चलिए ठीक है सर, समझ गया हूँ। 2.5 का स्क्वायर जो वो रेज हुआ है पावर।
Yes, so that's why we concluded that it's second order.
ओके ओके सर, ठीक है।
Okay. Using a large excess of water is a first order reaction. The graph shows the result obtained. Draw the structure of the organic product formed in this reaction. Yes. When this C6H5N2 positive, that's a diazonium ion, react with water, then what would form? Yes, can anybody recall? It's a preparation of phenol. We got a phenol over here and the nitrogen gas escapes. So they are asking for the structure. So you would draw a benzene ring having an OH group bonded to it. Is this clear? Use the graph to determine the rate of reaction at 100 seconds. Show your working. So see, this is very important thing. They didn't ask you to determine the rate of reaction for 100 seconds. They ask you to determine the rate at 100 seconds. So for that, at 100 seconds, this is the point. So what I have to do, I have to draw the tangent on this point and then find the gradients.
सर एक सेकंड बताएंगे ये फिनॉल वाला कौन से लेसन का हिस्सा था?
You can find in the subtopic of phenol and as well as in the reactions of phenylamine both.
सही सही.
1 minute. Polymer halogenuridine in phenylamine. No, I think I did it in phenol. See, here it is. Then on warming with water, OH is displaced. N2 is displaced by OH, forming nitrogen gas and HCl would form.
जी.
Okay, so at 100 second, I have to draw the tangent. No. Yes, now it like that the tangent is at 100 second. Now you got a tangent. Now find the rate. Yes, can anybody tell me the value? If anybody have a hard copy, do it and tell me the value.
तो थोड़ा ऊपर कर दे।
In this case, I'm getting 161718. So it is around 175 and here it is 280. So 0.
0.25 exponent minus 4.
1 minute. 0.0175 divided by 280. Yes.
6.25 exponent minus 5.
6.25 exponent minus 5. Okay. Is this clear to everyone? Now, sketch a concentration time graph of a zero order reaction. Use your graph to suggest how successive half-lives for a zero order reaction vary as the concentration of the reactant decreases. Indicate this by placing a tick in the appropriate boxes in the table. So if you recall, whenever there is a zero order, the successive half-life would actually decrease. In first order, the successive half-lives would not change. And for the second order, the successive half-lives would increase. So here I would put a tick. And the other thing, if you recall for the zero order, in zero order reaction, the concentration change is a constant, that the concentration of the reactant is changing with the same rate without any effect. So the graph would be like this only.
सर अब एक सेकंड के पीछे जाएंगे
Yes. Here.
जी तो ये 260 पे आ रहा है ना 280 पे तो नहीं आ रहा ना नहीं नहीं 280 पे ही आ रहा है
So I made over here on the screen. So there might be a,
सही ठीक है
accuracy problem over here. So if you are using the hard copy, so do take your values that you have got over there. Okay.
जी
Yes. Is this clear to everyone till here?
Yes,
अगर
sir.
फर्स्ट ऑर्डर का होती तो किस तरह बनता?
Sorry.
अगर फर्स्ट ऑर्डर का तो किस तरह बनता?
If it's a first order, okay. Let me tell you, for example, if the examiner asks you for the first order, so how you would make it? For first order, there is no change in the half-life, okay? And for the second order, the successive half-lives would actually increases. So for first order, what you would do, that is manipulation, not the exact thing, because you have to make it rough. So for example, you would make a point over here, that is your initial concentration, okay? Then if I look at this, can I mark this No, not this. If I mark this, isn't it this is the half of the initial concentration almost? Yes.
Yes.
So this is my first half-life, okay? Then what I would do, I would take the half of this one and I would make another thing like this, but I have to make sure that these two gaps are exactly same or almost same. Now afterwards, I will draw the graph like this for the first order. Sorry. So it would be a curve like this, and then afterwards, you can erase these. So it would be for the first order. Is this clear?
ठीक है.
Okay. In the same way we would do for the second order. First, we would mark the initial concentration. Then half of it. And here I would go down earlier. Then take its half. Now I would extend it. So see, my second half-life is increased. And now I would make a graph or a curve like this. That would be for the second order. Is this clear?
ठीक है. ठीक.
Okay, now question number 8. State and explain the relative rate of hydrolysis of acyl chlorides, alkyl chlorides, and aryl chlorides. So, if you recall, acyl chlorides are the one having chlorine bonded to a carbonyl. In alkyl chlorides, chlorine is just bonded to a alkyl group, and in aryl chloride, chlorine is bonded to benzene ring. So, among these three, acyl chloride is the one which hydrolyzes faster or fastest. The hydrolysis of the rate of the hydrolysis of alkyl chloride is actually moderate. And aryl chloride would have a slowest rate of hydrolysis. Now, for the explanation, in acyl chloride, chlorine is bonded to C double bond O, which is electron donating, which is electron withdrawing due to the electronegative oxygen atom, which is electron withdrawing hence carbon chlorine bond gets weaker, is this clear?
सर कार्बन और क्लोरीन के बॉन्ड से हाइड्रोलिसिस का क्या ताल्लुक है?
Am I audible to everyone now?
जी जी
Yes, is my screen is shared now?
जी जी स्क्रीन शेयर कहाँ हो रही है?
Okay. So I was doing this, but I think Zoom was stuck. So when we hydrolyze it, on hydrolysis, the ester link is broken down. Okay, let me explain this. I don't know whether you guys understood this or not.
वो असाइल क्लोराइड और अराइल क्लोराइड में फंसी हुई थी.
Okay. Now is it showing to everyone properly?
जी जी
Just give me a minute. Okay. Just tell me, is this is understandable to everyone? This part?
जी
सही दोबारा
Yes.
समझा देंगे?
Yes, sure. So the thing is over here that in this is an acyl chloride, this is an alkyl chloride, and this is an aryl chloride, right? So in acyl chloride, this oxygen withdraws the electron, and due to this, this bond gets weaker. Here, alkyl is electron donating in nature, so it induces its electron towards chlorine. As a result, this bond stays as a strong bond. And here what would happen that chlorine actually overlaps its lone pair in the p orbital with the p system over here of the benzene ring. So here the carbon chlorine bond is the strongest bond. So obviously if it's the strongest bond, so it would be very difficult to hydrolyze this one. To hydrolyze this one, it would be relatively easier, and this one can readily hydrolyze because the bond is weaker over here. And that's what we have mentioned over here. Is this clear or still confusion?
ठीक है.
Okay. So if we look over here, there is an ester, this is an ester, and here we have an amide. So on hydrolysis, the bonds are broken from over here only. So when the bond is broken from here, I got CH3O, and to that O, H is attached, making methanol. In the same way, here I got CH3O, and to O and H is bonded, making methanol. And here I would get CH3, CH2, C double bond O, and to this carbon, the OH would bond. So see, I got first product, I got my second product. Is this clear? So CH3OH and CH3, CH2, CO2H. Yes, is it clear to everyone? Okay. Now, the third product would be the center part that is left behind. So first I would make this center part. over here. Here I have a nitrogen. Okay. So see, from here the bond is broken. So here I've got OH. Here the bond is broken. I have got OH. Here the bond is broken. I would get H. So that is the structure. Is this clear? Yes. Now. Okay. I think we would do this in the next class because I have a right now session with the AS level as well. It takes a little time, so we will do it in the next session and then proceed to the new paper. Okay.
He's saying.
Okay. Take care, everyone.
Allah Hafiz.
Allah Hafiz. Allah Hafiz.
Allah Hafiz.
Allah Hafiz, everyone. Allah.